So thanks to all those in the audience tonight. I see a number of people I know, welcome, and a number who I don't, and I look forward to getting to know you. Our presentation tonight is not going to be highly technical, but the three of us in the Naval Architecture team currently at UNSW Canberra will contribute. As Phil has said, I've got the privilege as the program coordinator, but I'm joined on this endeavour by David Lyons and Ahmed Swidan. What we want to say, and the message we'd like to get across tonight to you, is that we are open for business. We are excited about the future in standing up a new Naval Architecture degree program at UNSW Canberra. But we also want to acknowledge that it is a work in progress. It's a little bit like the Field of Dreams, Kevin Costner movie. We look forward to welcoming the first graduates, undergraduate students into the program next year, but we've built a program and we're waiting for them to come. But our role tonight is to brief you on our planning and our aspirations. Where we want to differentiate ourselves is to be building a world's best practice program that's grey ship focused, particularly focusing on Navy's needs and the Australian Navy in particular. We want to be known for providing an education that develops the relevant and requisite understanding and discipline skills that are appropriate through an undergraduate program, through providing a strong theoretical framework and practical application. And we want to build on the tradition of UNSW in doing this at another place. It might be seen as a transfer of the highly respected discipline from the Sydney Kensington campus to the Canberra campus of the same university. But we want to stress that while building on that foundation and that reputation, we aim to tailor the program specifically for Navy, as I said, in support of the current Defence White Paper and the continuous Navy shipbuilding policy that's before us, and so exciting for us as an industry sector and the government policy that underpins it. And also, we want you to walk away tonight having learned a bit about the Australian Defence Force Academy and its uniqueness as an institution, and positioning the program here in contrast to Kensington provides significant opportunities for the program and the discipline of naval architecture to thrive well into the future. So the outline of what I want to talk to you about, because I'm the old man with the grey beard that's been around ADFA for some time, I want to introduce you to our environment, addressing naval architecture education in Australia broadly, talk a little bit about the relationship between the University and Defence and the Defence Force Academy and how that works. And then that'll lead into a discussion of our academic planning in the first instance for the undergraduate program, and then aspirations for things beyond that. So to our environment, naval architecture undergraduate degree and education in Australia, and indeed Australasia, has been built on the back of UNSW's endeavours, where the first graduate was produced in Brian Robson in 1963. And it was quite a long journey until any real competitor on shore, or at least within the Australian context, in Tasmania was established, where AMC became the second institution to offer naval architecture as an undergraduate degree program. And the first graduates out of that were Michael Hoon and Gregor McFarlane back in 1992. Since the late 80s, then the two programs have had coexisted up until 2017, when UNSW Sydney management decided to close the program there. But as one door closes and another opens, and that opened the door for UNSW Canberra to step into the gap. It did take us a little while, but from 2022, we'll be open for business, as I said, with a Naval Architecture program at UNSW Canberra. Clearly, maybe AMC thought that they were going to be the only game in town for a little while, and they enjoyed that, but we're back on deck in a collaborative, cooperative, and I guess partially friendly, competitive game as we both work towards educating the naval architects that will be necessary to support the shipbuilding program going forward. I think most of us would recognise that naval architecture education is built on a mechanical engineering foundation, and that doesn't change. And indeed, UNSW's history from the 60s was to invite students from anywhere else in the country or world, really, who had 2 years of mechanical engineering under their belt to transfer into third year to then graduate with a naval architecture degree in what we'll call a 2+2 model. UNSW Canberra will certainly continue with that idea, and indeed AMC has formalised a 2+2 model themselves, where they would accept transferees, and they have established formal relationships with Edith Cowan, Flinders and Auckland, such that those other 3 institutions, at least on their handbook, suggest that they've got naval architecture programs, but the students transfer to Launceston AMC for 3rd and 4th years. So the same opportunity exists with our program going forward, that do 2 years at Melbourne or Sydney or Newcastle or wherever, and then transfer to Canberra to complete the naval architecture degree. So we're continuing with what had been well established in Uni in New South Wales. If we talk about just Uni in New South Wales at a glance, a distinctive for it is that it is one of the group of 8 universities, one of the research-intensive universities in the Australian context. It has 3 major campuses in Sydney, so that's at Kensington, at Paddington for the art and design faculty or part thereof, and at UNSW Canberra. So the university is organised with 6 formal faculties across these 6 discipline areas and 1 college. Now, a college in the university language is a multidisciplinary faculty equivalent, and that college is UNSW Canberra. If we think about the engineering school at Kensington, you know, there's electrical engineering, mechanical engineering, all of the schools within the engineering faculty are engineering. But as you'll see a little later, UNSW Canberra is a multidisciplinary faculty, and that adds to its strength in our military context. Broadly, the university comprises 47 schools and 125 external centres and institutes, and is in the top 5 to 10%, depending on whose rankings you read about, in terms of world universities. We're one of Australia's best in engineering, and these measures are across the university as a whole. So dating back to when Brian Robson graduated, UNSW Sydney, Kensington, never had its own towing tank. He used one at the University of Sydney, which I believe no longer exists. I'm not sure what is there now, whether they're growing hydroponics in a channel or they've filled it in. But in the same way, while AMC has facilities, we won't be aiming to replicate them, but we want to be complementing activities in our naval architectural space. So let's turn then to talking a little bit about UNSW and the relationship with Defence. When you arrive off Northcote Drive at the Defence Force Academy, you're greeted with this sign that clearly marks the partnership between the university and the Commonwealth in providing education in a military context at the Defence Force Academy. So the history here between the two organisations reaches back to discussions that were happening within Defence in the 1950s, where it was recognised that it would be valuable to have university education part of officer training. And so the RAF, the Air Force, was the first to step in this direction and formally established a relationship in 1960 with the University of Melbourne to incorporate a degree into the programs that were being run out of the RAF College or the RAF Academy at Point Cook in Victoria. It followed that Army and Navy both started to negotiate with the University of New South Wales, and it took a few years for things to happen, but in 1967, for both Army and Navy, arrangements were established whereby UNSW would be the provider of that university education that was sought and forecast back in the 50s. So in 1967, UNSW established a faculty of the university, labelled the Faculty of Military Studies, at the Royal Military College, Duntroon, which is in Canberra. And through that faculty, students of Army would have the opportunity to gain an arts, science or engineering degree. In parallel, an arrangement was established where Navy students, midshipmen, would study 1 year of basic engineering science type subjects at HMAS Creswell, and then they would transfer up to Sydney, often being billeted at HMAS Watson, and attend the UNSW Kensington Campus to complete the next 3 years of their degree. Even from these times in the 60s, there was talk about creating a tri-service Defence Force Academy for Australia. And this grew legs in a way in 1976, when there was approval in principle for the Tri-Service Academy given under the Fraser government. In 1980, a bill was passed through the House of Representatives that established ADFA as an entity, and then subsequently a formal agreement between UNSW and Defence was entered into for UNSW to provide that education at ADFA in a tri-service environment. And what happened, post 81, construction of the facilities, and the doors were opened for the first students in 1986. And in essence, the Faculty of Military Studies, who are at Duntroon, which is just over the hill from the ADFA campus, moved across to form the nucleus of what is now University College. And periodically since, over the last 35 years, there have been contracts renegotiated for the continuous delivery of UNSW education in a defence environment on a military base, which is the Defence Force Academy. So construction here, this is part of the engineering set of buildings on campus in the 1980s, and a photograph probably circa about 2005 of a graduation parade. So if we think about the campus, it's sort of all of these white buildings, and it sort of spans off to the left and right out of picture. Over the hill to the left of the picture and to the south is Duntroon. So the Royal Military College is over there, and that still operates for direct entry training for officer cadets. Working north from the ridge that separates Duntroon and the ADFA campus, we have these buildings, which are the accommodation blocks for the cadets and midshipmen, the cadet mess, the original gym and swimming pool. There is a building now here with another gym. And as I say, this is circa 2005. A number of these buildings have been further developed or additions have been made. But if you drew a line through the centre of this axis, through the centre of the parade ground, everything to the south is effectively military. This is the military building. This is the main admin building, which is shared between the university and the military. This is the university library, or the ADFA library, the officers' mess, and then all buildings to the north represent the university campus. And the ones that I showed the construction photos of were out in front of this. This is building 17. We'll talk a little bit more about that, but up out of shot here would be a north western corner of the campus, which is building 20. But yes, this axis broadly splits the campus between the military and the university, as both the military deliver military training and we as the university deliver university education to trainee officers, officer cadets and midshipmen in the main. So UNSW Canberra, also University College, as I explained earlier, multidisciplinary faculty equivalent of the university. So when all the deans meet, our head is a position called the Rector, but the Rector is a dean equivalent in the same way that college is a faculty equivalent. Our objectives in UNSW Canberra targeted towards defence, enhance the intellectual edge of Australia's Defence Force, support the ADF, the Australian Defence Force Joint Professional Military Education Program, and with an aim to develop future global leaders. And currently, the way we're structured is with 4 academic schools, the School of Engineering and IT, which we'll call SEIT, and which is one of the largest schools within the University of New South Wales as a whole. We have a School of Science, a School of Humanities and Social Science, and a School of Business. As the students walk across that axis that I pointed out previously from their lines or their accommodation blocks to the south, they come past what's colloquially referred to as the tree of knowledge as they make their way towards university classes. ADFA fundamentally was established as a tri-service institution. And so our students are a little bit different to most civilian universities where they wear uniform. They might be seen to be wandering around the campus at times with things that look like weapons. We're told that they're not loaded, but it is an interesting dynamic. We've got young people who are aspiring to be leaders of the Defence Force that we're teaching. And it is an exciting cohort to be engaging with. They're bright students, they're enthusiastic, but they've chosen a career broadly in uniform. So as I said, the history 35 years ago and from establishment, it might have appeared on the outside that the university was predominantly an undergraduate teaching institution, and perhaps that representation of it in 1986 is reasonable. But 35 years on, we're certainly now a well-rounded faculty of the university. We're at a state now where the number of enrolled postgrads in both high degree research degrees, so masters and PhDs, and those doing coursework now outnumbers the undergraduates. At the postgraduate level, UNSW Canberra operates as a normal civilian university with no mandatory connection to defence, and we have a fair number of international students studying with us. But clearly there is a strong connection to defence because a lot of our activities are still defence related. At the undergraduate level, until 2011, all undergraduates were in uniform. That's changed, and the current demographic represents the dominant uniformed military cohort, But we do have defence-sponsored civilians, and we do have a quota of non-defence connected civilian students as well. And the Naval Architecture program is open to all three groups of students. So we'd expect to have some of the Navy students who are aiming to become marine engineering officers. In the past, they've done a mechanical engineering degree as a pathway to MEO, but we're introducing the naval architecture, and that gives them sort of two academic pathways for the same career. Of course, the civilians, whether they are defence sponsored or paying their own way, have the opportunity to join defence, either in CASG or those sorts of organisations, or in the shipbuilding sector. So just talking a little bit about the cohorts, the uniformed group, nominally 11 to 1,200 undergraduates across the college, so across the 4 schools, and they comprise what we would think of as the training officers, the officer cadets and midshipmen, who would be our own defence force or foreign military. So we could have students from New Zealand or Singapore or other friendly military. And we might also have students in our classroom who sit within the advanced squadron, who are mature age students who are converting to the officer ranks. They may be soldier, sailor and airmen who have been offered a commission to come and study engineering. As the civilians, we have the DCUS students, so that's an acronym for Defence Civilian Undergraduate Scholarship Holders, and CASG tends to look after the bulk of these, and generally they receive a full tuition fee coverage from their scholarship, a few $1,000 bursary, and paid work experience for the nominal 3-month summer period. Now, the non-defence regular fee paying students are a little bit on their own. They are paying their own fees, but it was negotiated between the university and Defence to allow up to a quota of 40 civilian students within SEIT year groups across our disciplines. We haven't filled all those positions now, and indeed this was established, a little bit of history was as Canberra was, and the ACT government was looking to the infrastructure that was being developed in the Canberra region. There was nowhere in the ACT region where you could study traditional engineering degrees. ANU runs a systems engineering program, and the University of Canberra has wound back their engineering. So if students want to do civil engineering, for example, to support the light rail system in Canberra, the ACT government approached the university to see whether that could happen, and we've broadened the intake that 40 civilian fee-paying students on top of those that are captured within the DCUS scheme represent the civilian cohort, but not too many that it's going to remove the military and defence flavour of ADFA, which is a defence base. So just a few words about each of the 3 services and how they progress students and trainee officers through the programs. School leavers would need to, if they're wanting to wear uniform, to join the ADF, and so they need to apply through Defence Force recruiting to join the Army, Navy or Air Force, ultimately going through the appropriate officer selection boards, and at the same time they'd need to apply through UAC, the University Admissions Centre, with the appropriate grades to qualify to become a university student of UNSW. But once in place, once in uniform and offered a position, the 3 services over 5 years provide an opportunity for the trainee officers to, 1, go through the military training at ADFA, the relevant university degree, and here I'm focusing on engineering degrees, and the year in service, in specific service, single service training. Army does it where they would send the school leavers to ADFA for years 1, 2 and 3. They'd graduate from ADFA after year 3. Then they'd all ship over to Duntroon for a year of military training, there to actually gain a commission, and then they'd come back in their 5th year to complete their 4th year of the engineering degree. Navy does it slightly differently in that in the beginning, when students came to ADFA in year 1, it wasn't till they got to really year 5, like Army, that they first went to sea and then found, oh, this is not for me, and so Navy was losing a lot of students. So they introduced what they call the NOYO scheme, the Naval Officer Year 1 scheme within the Navy. So they take school leavers directly down to HMAS Creswell. They spend some time there in Navy training and then put them on a ship, ideally during that 1st year. Then they arrive at ADFA in year 2, 3 and 4, during which they would graduate from ADFA, and then they do the 5th year of their engineering degree in year 5. Air Force bring the students directly to ADFA. They graduate, they stay in the 4th year to complete their degree, and then they do their single year of service in the Air Force in year 5. But at the end of year 5, they've all graduated from ADFA, 3 years of training, graduated from the university with a 4-year degree, and they've had 1 year of single service training. So we have a graduation parade after 3 years, and at least for the arts and science students, the day before this parade happens, they would have walked across the stage to gain their degree. But this is sort of a delayed gratification for the engineers that they have another year to go. So that's a little bit of background about the environment, the types of students we have, and what ADFA is all about. So I just want to turn attentions now to the broad framework for how we're aiming to set up our naval architecture program and the academic planning. Within SEIT, School of Engineering and IT, from next year, we will have 5 engineering disciplines, so naval architecture joining civil elect, aero and mech. And we actually have 10 undergraduate engineering programs, because for each of those disciplines, we have an elite program called the CDF program, variant of each of those 5 disciplines. So it attracts or is open to students who finish school with an ATAR of 98 or better, so they're in the top 2%. And the program for them is slightly different, providing a greater opportunity to engage in research earlier in their degree. So thinking a little bit about the numbers we expect into our naval architecture program, the historical numbers from UNSW Sydney from 1963 to 2018, when the last graduate walked across the stage up there. 413 students have graduated, of which Phil and David Lyons have had significant part to play with a number of those. And Laurie Doctors, if he's in the room, even more so. And that represents a long-term average over that period of 8 graduates per year. I am a graduate of this program, as is David, and I think the year that I graduated was the first time we'd broken into double figures. But what we were hoping to ramp up to is a long-term average, or a rolling average of 10 to 15 graduates a year, where the cohort will be a mix of uniform and civilian students, as I said. But needless to say, the tick in the boxes there for both the staff and the students, that it's a fantastic staff-student ratio. Nominally 4 academics, 3 of us, as I'll talk about in a minute. We're looking to hire a 4th for 10 to 15 students. How good is that? From an accreditation perspective, the program at Kensington had been accredited for many years, and the 5-yearly accreditation visit to UNSW Canberra was conducted just over a month ago, back in August, with representation on the accreditation panel from Ryder. That accreditation process in August moved to re-accredit all of the existing engineering degrees, so that's Mech, Aero, Civil and Elec, and to provisionally accredit the Naval Architecture program. So again, great ticks in the box through those processes. And our provisional accreditation is conditional upon us providing a submission next year on how we're going as we get the first students into the program. Note that full accreditation is just not possible until we produce graduates. So we certainly, in the next 5-year cycle in 2026, would expect our program to be fully accredited. So digging down into the detail a little further, the 2 programs I've spoken about, the standard one, 4-year honours degree, and the CDF variants, indicative ATAR of 92 for the civilian students coming into the BE Naval Architecture. So we are looking for the top 8% of students in the country, or the top 2 in the case of CDF, to join us. And within this program, we have 8 specialist naval architecture courses. I'm not going to go into great detail about these. The fact that the presentation is being recorded, there is more detail in these slides that you'd be able to go and read, but they clearly build on each other. Naval Architecture Practice and Ship Hydrostatics provides a foundation for the fundamentals of hydrodynamics, ship structures and design of ships, which then feeds the application courses in the design project and a ship propulsion course. So this is the full course. University degrees, or ours at least, are 8 courses per year, 4 courses per semester. Each course represents engaging a student for nominally 150 hours of their life. And as you see, the ones that are highlighted here, this is 1st year, 2nd year, 3rd year, 4th year for each of the 2 programs. Let's just home in on the standard program, 3rd and 4th years, 8 3rd year courses, 8 4th year courses. They also do a thesis, so it's a common course code for all of the engineering students, but you would expect that the thesis, part A and part B, would also be naval architecture founded, and the 2 electives in the standard program would be related to naval architecture. So we might think, while we're teaching 8 courses that differentiate from Mech and Aero, from a student perspective, there are 12 of the 16 in the 3rd and 4th year that are naval architecture related. A common 1st year with Mech and Aero, and an almost common 2nd year with Mech and Aero. And this structuring of courses is very similar to the former program at Kensington. As I said, I'm not, this slide's there really for you to come back to, perhaps in the recorded session, or you could go to the university website to see a little bit more detail in the handbook descriptions. And we're in the process of fleshing out exactly what the course material will be for each of these courses. But clearly our objective is to teach these courses with a grey ship focus. So where perhaps before there might have been general discussion about high-speed craft referring to fast ferries, we might be talking more about patrol boats for Navy, but we would mention on the side, there's fast ferries as well, and some students may elect to dig deeper into the commercial sectors, but we will be using, where we can, examples that are relevant to Navy. So just a little bit more of a picture tour of the campus. It is a nice campus, particularly during fall colour, quite well appointed. Some of these buildings that we're seeing, particularly top left, weren't there in 2005, that aerial photograph that I showed you earlier. This is some of the development of the campus that has taken place to create some more, or just some more teaching spaces, and top right, some more open areas. When it was, all of our undergraduate students lived in the Lyons, ate in the mess. Perhaps these communal spaces weren't quite so important, but certainly with civilian students on campus now, we need to be providing greater opportunity for the students to collaborate and work together in these learning and teaching spaces. So as I said, the aerial photograph had this building 20 in the northeastern corner out of camera shot. But as we zoom into this corner, building 20 is in essence the Naval Architecture headquarters. It's where our offices are. Mine, Ahmed's, and David's will be, and it's in building 20 where we have our wet lab, or predominantly hydraulics lab. We have a number of smallish seminar rooms, which I can imagine for our cohort would be the types of teaching spaces. So, visualize a naval architecture class here. It'd be fantastic to fill all of those chairs. A simulated workplace where our junior engineers are connected to online design tools, learning management systems, and applying the theory to practice and defending their design decisions to staff and peers as their learning deepens from knowledge and skills to application. In essence, that's what a university education is all about: fundamental knowledge, and then developing a passion for lifelong learning to apply what they have learned to problems that they haven't solved before. That's the difference between training and education. Training will teach you to respond the same way to the same stimulus. Education has got to provide an environment where people are confident and capable to tackle problems that they haven't seen before. And certainly there's some problems we haven't seen before going forward. We can think about what the new submarine might look like and might require from some of our students. Our program broadly will be surface ship based, but again, we will provide some insights into the differences between surface ships and submarines as appropriate. But perhaps that's an opportunity for us in the future to grow some further offerings in the postgraduate level, to look at other things like nuclear submarine propulsion or the like. We did engage nearly 12 months ago with industry. We put out a survey over the sort of December, January, February period last year and early this year, and a number of organisations identified themselves as stakeholders in our program, and they represent Navy, class societies, government and industry. And those that haven't necessarily formally stepped forward, we certainly invite you to engage with us. But the list on the right shows those that have explicitly come forward to say they want to be engaged with us in building this program. From those stakeholders, we asked them, well, what do you really expect from a graduate? And as is reasonable, most of them, the comments align with the stage 1 competencies that are published by Engineers Australia. But the various potential employers, they're looking for well-rounded engineering skills, analytic, mathematical and scientific, foundational knowledge and principles, but working knowledge of technology, etc. The ability to understand application, the how and the why, basic understanding of rules and standards, federal and state and international requirements, class and sustainment, broad enough to be productive and deep enough to be productive after graduation. sound technical knowledge, practical experience, and then the softer skills that we might think of: communication, administration, report writing, project management, and of course, an appropriate attitude. So these are things that we aspire to develop in our students, and picking them up in third year, they would have a strong foundation leading towards a number of these competencies already in the ADFA context. Our staffing and resources, as I said, currently 3, but we're in the process of recruiting a 4th. Also of attracting students. So anyone out there in the audience who knows of someone who might like to become a naval architect, point them our way. We'd love to talk to them. And thinking of resources, we'll leverage the broader resources of our school, of our university, and that could even include the Water Resources Laboratory at Manly, who are actually providing us some wave makers. The military side of the house, defence in general and Navy in particular, and AMC. I want to acknowledge the sponsorship of Navy, and particularly the support of the head Navy Engineering, H&E, currently Rear Admiral Kath Richards, but also Rear Admiral Col Lawrence. When he was in the chair, he was pivotal in helping us get the approvals and the support of Navy to stand the program up. And we certainly anticipate support from a whole range of guest lecturers that we would invite in to participate with us, from Navy, from industry, government, and those who are particularly subject matter experts. So what does the school have? We have a range of laboratories, but as I said, in Building 20, we have what we call our wet lab. It was originally set up for civil engineering coastal work, and so we could create a little basin if we wanted to, but in that space, we'll have a couple of flumes, one, if not both, fitted with wave makers and carriages. We're not anticipating that these would be sort of research quality data gathering systems from the naval architecture perspective, but they'll be fantastic demonstration rigs and support undergraduate thesis work. We have a range of arm field fluid benches, and we're acquiring the arm field ship stability rig. And then, of course, all of the other wind tunnels and material testing laboratories and student workshops and computer labs that are within the school and the faculty or the college. Key software we'll be aiming to use McSurf from the Bentley suite. Our students are exposed to CATIA in first year, so I imagine we'll build on what's available to us through DASSO's 3D experience package. And we also have available the Autodesk suite and packages like MATLAB, and in FEA context, ANSYS and others, in the CFD context, Star CCM and others. And under evaluation is whether we will purchase and utilize NavCAD's HydroComp or the Wolfson units suite. So again, just a few photographs. This is the existing flume. Another flume will be built parallel to this with a slightly larger cross section. And this is the newer one is the one that we'll target first, at least with wave maker capability. Okay, that limits us potentially to zero velocity, but at least we can model waves and ship motions to some degree. We could model resistance with the flume actually running a current, so stationary model against moving water. We do have a few ship models. This is set up that has supported my naval architecture elective for the mechanical and aero students in the past, and will continue to use this and others similar to it going forward. And in the background, you can see one of the hydraulics benches that we have for hydraulics labs that will be appropriate. We've got flow benches, etc. There's the potential to develop some rigs that would allow us to use the ADFA Pool as a potential model test facility, in the same way that we have a body of water, Lake Burley Griffin, and the ADFA Boat Shed down in Yarralumla Bay, that may afford us another open water lake test facility going forward. The cooperation we spoke of earlier with AMC, we have agreement with AMC to visit and use their facilities, and that will lead to a semester 1 fourth year study tour, which will be part of the students' work experience program. And there's certainly a precedent for UNSW students going down to AMC, with students from Kensington having gone down regularly in past years. And certainly our desire, as I said, we're not trying to compete. We're not going to be building a new towing tank or wave basin, but to strengthen existing collaborative, cooperative, collegial relationships with AMC. And both David and Ahmed will talk a little bit more about that. As I said, we're not going to replicate Australia's premier facility in the towing tank or the model test basin. We'll go down and use that and allow our students to understand what resources are available broadly within the context of the national shipbuilding policy and resources. But we will institute a training cruise, and the possibility is there to use Bluefin, AMC's vessel, for that, and or Navy assets such as Navy's training vessel, MV Sycamore, which is based out of Jervis Bay. So at this point, having provided an overview of the our environment and our course and program planning, I'll hand over to David to say a few words.
Yeah, thank you very much, Warren. I think we're still driving the slides, so if you could go through to the next one, please. And as Warren just touched on, and I'll just provide a brief additional detail. Up until the closure of the Sydney Naval Architecture Program, each year our hydrodynamics students in third year attended AMC to avail themselves of the facilities there. These are just some photographs from the latter stages of that engagement between us in Sydney at the time and AMC, showing the cohort at the time, which numbered about 7 students in that particular year. Other than attending the campus at Launceston and the facilities there, the group also travelled south to Hobart to visit Incat Tasmania and Richardson Devine Marine as well. Both don't need much introduction, if any, global reputed shipyards in mainly fast ferry or fast high-speed craft construction. Next slide, please, Warren. Meanwhile, back up in Sydney, again in third year, we each year attended Roselle Bay to the Sydney Heritage Fleet to conduct an inclining on one of the Heritage Fleet tugs. This particular one shown here is the Currawong, and you can see Phil Helmore there, literally in the engine room. Yep, the tea room on the bottom right, but the engine room up the top there, where Phil looks like he's setting up the pendulum in the bucket of water. And the students, as a group, are involved in the data acquisition, the shifting of the weights from side to side, and they produce a inclining experiment report in the form of a brief stability book, and that whole thing takes an entire morning. We've usually been blessed with good conditions. So hygrometers are used, temperatures are taken. It's a real world experience. Now, although this is what we did do, we fully intend to continue to do this sort of inclining experiment, hopefully with the kind cooperation of the Sydney Heritage Fleet. So that will remain an integral part of the program going forward. It's just that we'll be bringing the cohort of students up from Canberra to do that. Next slide, please, Warren. One of the other visits in Sydney, which we're hopeful and expectant really to be able to continue this or similar visits, was aboard one of the Manly fast catamaran ferries designed by 123 Naval Architects in this case, and you can see Rob Tulk there, one of the directors of 123, with the cohort of that year. This is in, I think, 2017. So again, this is the third year cohort, so it's probably 2016, I'm sorry, but anyway. We, through good management, really managed the time so that we can take the cohorts around to a number of these excursions in Sydney. One of the previous slides that Warren showed indicated that there'd also be visits to classification societies. We expect to continue those with Lloyd's Register or DMV, not to exclude some of the others who have offices in Sydney. Similarly, we in the past have enjoyed visits to INCAT, Crowther, up at Belrose. Our focus is grey ship, but we are blessed to have such a large and productive consultancies based in Sydney in INCAT, Crowther and 123, not to exclude some of the other offices there, that we expect to be able to continue to conduct those visits. A lot of the staff in those offices are our near-term graduates as well. Next slide, please, Warren. I saw a question flash up about dry docking, which we can discuss at the end in Q&A, but just as an intro to that, each year we have attended the Garden Island Naval Dockyard, where we've been down on the dock floor as well as down into the pump room. We've also been in the dockyard office, and on one occasion at least that I can recall, and we'll be doing this again in the future with the close cooperation of Talus and Navy. We expect to be able to show the students a hands-on docking operation, or at least a part of it, depending on the timing on the day. The facility has preference or priority given to Royal Australian Naval vessels, but on this occasion, of course, we can see that the Sea Road Mersey was in the dock on the day. Next slide, please, Mike. So I've been talking about the field trips, and we'll build a whole program around these that essentially for the Sydney-based excursions will be for the third year students, whereas we will shift, or we will have the AMC field trip in Launceston for fourth year. Ahmed is going to speak very shortly, and he is in effect our portfolio holder, if you like, for dealings with AMC, having been at AMC previously. So I'll leave it to him to speak some more about that if he wishes. We Also, every second year, we'll be taking the students to the Maritime Conference and Exhibition, so-called Pacific, which will mean that there'll be a year 3 and a year 4 cohort together because it's held every 2 years. Other opportunities as they arise and funding is available, we expect to have funding, so it'll be a case of timetabling and movement of people more than a money issue. Will be visits to Adelaide in particular because of the enormous shipbuilding operation going on there now and into the future. Garden Island I've mentioned, and Creswell, and other sea time or experiences aboard Royal Australian naval vessels, which will be facilitated for us by the head of Naval Engineering or her delegates. We've got strong support there, so we're in a very good position to flesh out the hands-on experience as much as possible for the students. Next slide, please. Okay, just very briefly, my interests, they're not purely research. I've had a fairly lengthy career in industry, so I come with a practical and practice-based approach to engineering education. I've employed a lot of the graduates that, when I say a lot, probably about 6 or 8 of the graduates, mainly from Naval Architecture, and who were well prepared and helped in their journey by Phil Elmore and Laurie Doctors and others. So I aim to approach the task of teaching in naval architecture again with a very fresh pair of eyes, and not seek to just replicate what we had before, but to meet the market with what our stakeholders are telling us a good round naval architecture graduate should be. As Warren has said, our marching orders, as it were, is primarily, or at least firstly, to address defence-orientated projects, graduate focus. So once we have undertaken the key task of launching this undergraduate program into the stream, we will start to bolster our research presence as well. I know Ahmed and Warren are going to come back and talk a lot about that themselves. I have some other interests that are listed there. They're fairly self-explanatory. Some of them are fairly, I've been involved in them for quite a long time, in the areas of composites and yacht design as well, but now with a view to seeing how they can be applied in the broader shipbuilding sphere. Next slide, I think that's me actually. Yes, it is. So
thank you.
And handing over to Ahmed, who's not very far away. I'll leave it to Ahmed to explain.
I believe I won't make it long. I believe I won't make it long at all. Thank you, David, so much. Thank you, Warren, for introducing me. First of all, I would like to, I'm really excited about this cutting edge project that we are trying to stand up, and we are putting really our effort to stand up a unique naval architecture program in UNSW. First of all, as a brief on my background, I actually joined the AMC back in 2012, November actually 2012, where I studied there as a PhD student and also as a lecturer for the seafarers up to chief engineer level in the National Center for Ports and Shipping. Afterwards, I joined also the AMC staff, proudly joined the AMC staff as a lecturer in the National Center for Maritime Engineering and Hydrodynamics. During my time there in AMC, which spans over 6 years, I used and I utilized and I taught the facilities, most of the facilities around, but because it's huge, so I couldn't use it. Our aim in the new program is not to replicate any Australian facility which is already existing, but to build collaboration, build up like a unique program in collaboration also with all Australian facilities that already exists. So just as a brief, the last task I got it there in AMC, it was like the course coordinator for the maritime engineering, for the naval architecture, and even for the ocean engineering students aboard the Bluefin for the course itself aboard the Bluefin, which is just one unit or one course, one unit actually in AMC. Also, I used the towing tank, and my final year students there, just in 2018, they awarded the Walter Atkinson Award by Martin Renelson when he was like president of RINA in Australia. So actually, we are aiming to use the AMC towing tank, also the circular basin, the Bluefin, with some happy students here and the staff. Also, their unique facilities aboard the vessels, even it's old, but still it's working like a workshop inside, the gravitational tunnel, the diesel engines, the simulators, everything, you know, there in AMC, we are trying to collaborate and work it together. Next slide, please. So I'm not actually sure what I can add to this program, you know, after what David and Warren introduced it in the program, but I'll just give you a brief about our past and ongoing final year projects, which is run actually by mechanical and aero students. So actually we don't have any naval architecture up to now, but we are trying to make the flavor with the students. So say in 2020, we started just a concept design for a weak craft that is actually capable to fly and survive as a drone for the Royal Australian Navy. And we actually accepted as a journal paper this final year project, which run by a couple of students. This year, actually, we went through another iteration for the design project, and we extended the scope to make it actually like a submersible seaplane or a hybrid submersible seaplane. We actually configured by using the CFD simulations, both the underwater and above water performance of the vessels. That's like the above water CFD simulations, and that's like the pressure contours for the underwater. Also, we introduced the material design by our civil engineers here, and we used actually ultralight type of composites in collaboration with our industrial partners, Ron Allen and Thales. Hopefully, we are actually we got an acceptance to present these outcomes in the coming Submarine Institute Australia conference in 2021, and also in the UC DEF in America. Next slide, please. It's not only about the undergraduate projects, but we are also giving some flavor for our PhD students. So here is just one example of PhD outcomes that is working also to with the aim of this project to lower the risky visual detection of submarine masts, and you actually are getting some potential and promising results out of this project. Say, for an example, here for the merged foil, as you can see, it really decreases both the bloom height and also the drag force significantly. And I'm so happy, you know, to see this outcome, because also when I saw just a couple of months ago or 1 month ago for the European introducing some autonomous vessels, they use the same type of mast actually, which like the merged foil, which up to my knowledge, it's never been used before. Next slide, please. So it is feasible. Wow. So this is like my last slide, which is I just want to share with yourself some of my research interests, like doing full-scale sea trials, including powering and also estimating the resistance or the speed of the vessels, CFD simulations, ships classification and certification, experimental hydrodynamic tests, including the drop testing facility. If we can just run this video. which has been conducted in 2016 in collaboration with Auckland University while I was in AMC, and also towing tank experiments. And this is like the experiment that has been awarded the Walter Atkinson Award by reducing the slam by around 40% on 2 NPL models, and we just added that center bow in between. So it's like generic center bow, and that's like using the NPL catamaran model. For also parts of my areas of interest that I'm really scratching and going a bit in depth in this area, which is the ship recycling according to the Hong Kong Convention in 2009, which is coming into force or shall come into force in 2023, including the ship recycling facility plan, including the ship recycling cutting plan, the inventory hazardous material, which has been in force since last December 2020, and also the waste management plan. Also for applying the rules in ships design and construction. And say, for an example, in 2018, I provided a course for the Australian Shipbuilding Company. That course was aiming for mechanical and different background engineers to apply rules in ship conversion, and also for applying rules in ship design and construction. Parts also of my research area of interest, which is designing the mechanical systems aboard vessels, including the estimation of the propulsion system and the propeller interaction, hull interaction, and the design also of water desalination systems and energy recovery systems. And I got a patent within that regard for the new energy recovery system in 2016. Last but not least, the next slide, please, Warren. Sorry. This is just part of our final year students who presented their work for contributing the STEM education in Australia and the subsidy schools project by presenting 4 published papers in past Pacific conference. And here is Warren, who was going to take the lead again from me. Thank you so much for your time. Thanks for being interested in this presentation. Thank you.
Yes, so thank you very much, Ahmed. And just to close, a couple of comments I'd like to make. Some of the things that we can certainly leverage from the current SEIT activities into the maritime space, the naval architecture space, is the work that's going on in multidisciplinary design optimization. We've got a very strong group in this area at the moment. My own PhD work was in this space and looking at, how do you develop an understanding of specifications that are realistic at the conceptual stage of design. We also have another naval architect on staff within SEIT who is predominantly focused in this group, but teaching into the mechanical design courses in Professor Tababrata Ray. So he's another resource within the school with a naval architecture background. We have a strength in the school in autonomy. A lot of that has been applied to drones, and so aerial systems, and also a lot of work going on for land-based systems. So there's certainly the chance to broaden those activities to surface and subsurface vessels, as Ahmed has hinted about with the WIG projects in the last couple of years. And we do have a well-respected group working in impact dynamics, and then the clear extension from looking at ballistic profiles and material behaviours is to bring that into the maritime context, and particularly for Navy, looking at questions of ship survivability and vulnerability. In the 23 years that I've been at ADFA, I've supported a range of undergraduate and postgraduate projects in the past in the maritime space. We used Lake George as an open water test facility until Lake George dried up. We've conducted a range of various design studies, and a couple to highlight. The work of David Drowan on life jackets for encumbered personnel certainly drew on significant buoyancy calculations and trying to predict how much water would drown an unconscious person. And so we were down there using the towing tank at AMC with a mannequin. This is the mannequin, but David set himself up such that the mannequin modelled him, and he spent a lot of time in the water in different ways too, just trying to test where additional flotation was required. So that was certainly non-traditional naval architecture work, but certainly related. And Peter Hayes did his master's degree in looking at landing craft stability, particularly in beam seas. And again, his work took us down to AMC to use the towing tank. So we see these sorts of connections with AMC as things that we will replicate going forward. So to summarise the key takeaways, and I know it's coming up on 10 to 8, but I thank you for your patience with us. I think everyone has stuck with us. We'd like to state that we're certainly excited to be creating a high quality undergraduate naval architecture program that is grey ship focused. And we're standing up this program as our priority, and we acknowledge that it's a work in progress. Now, we will welcome our first students formally in 2022, fingers crossed. At least we'll get one. No, I'm sure we'll get more than that. But we look forward to welcoming them, and we anticipate producing our first graduates from this new program in 2023. We look forward to subsequently growing, as we've alluded to, relevant research and postgraduate coursework opportunities, which could be, how do we stand up a master's program to convert a mechanical engineer to a naval architect, for example, at the postgraduate level. Perhaps there'd be special other courses that would deal with extensions to what we can teach in an undergraduate program into submarine design or more detailed warship design or aspects of that, which could lead to thinking about, as I saw one of the questions, something around nuclear propulsion. We do reside within a strong multidisciplinary college and school, which has a unique relationship to defence, and we'll continue to leverage that. We appreciate Navy's support, and particularly that of HNE, past and present, Kath Richards, Cole Lawrence. We appreciate the cooperation of AMC and for our planned field trips and our visits and use of their facilities. We appreciate the engagement of our stakeholders, and we certainly invite all who are interested to join us. And we're keen to answer any questions arising today and in the future. Please don't hesitate to contact us at any time if you'd like us to talk to us about possibilities. We're open to that discussion.